Okay, so this financial math video is all about tricking the calculator to do a financial math problem for you that actually does not involve payments. So keep in mind that the TVM solver is set up to handle payment-based problems. We have a lot of our variables, the PMT, payment amount, the P/Y, payments per year, the capital N, number of payments, that all have to do with the payments. So if there are no payments, we would usually be using the formula for compound interest in our booklet. However, you can actually trick the calculator to do those types of problems for you. What you would do is make your payments per year a convenient number. Normally, for most people, that means the number 1. And then you set your total number of payments, which is your capital N, as your chosen payments per year multiplied by the number of years. So it basically is lowercase n, number of years, times P/Y is our uppercase n. So if you pick 1 to be your payments per year, then suddenly lowercase n from the formula and uppercase n from your calculator are the same. It does not say it here, and I should have put it, so I'll put it on the side. But obviously the payment amount, if there are no payments, is going to be $0. So we had some problems, practice problems 1 through 5 in the financial notes section that we originally did with the formula. So I'm going to go back right now and redo a couple of those with the formula and with the TVM solver, just so you can see the difference of how these would work. So practice number 1, you invest $5,000 into an account with 4% APR compounded monthly. How much is the account worth after 6 years, and how much interest do you earn? Right away, I see that there are no payments being made. I put the money in the account and I just let it sit there for 6 years. So normally that would tell me that I should use the compound interest formula out of my booklet, because that formula is designed to have no payments, just start amount, let it sit, and then figure out what you have at the end. So in that case, I would say, well, my principal value invested is $5,000. My interest rate, my R here, is going to be 4% over 100, because that turns it into a decimal for me. And then the lowercase k is how many times it's compounded per year. Monthly means that that would be 12 times a year. And lowercase n is number of years, so that's 6 years. So in this case, I think a lot of people do actually find it easier to use the calculator because you can just plug and chug. But let me do this here. So we've got 4 over 1,200 to the 12 times 6 power. So I've got about $6,353.71 is how much it's worth. Part 2, how much interest do you earn? If I then take that total amount and I subtract out the original investment, which was $5,000. Let me subtract out $5,000 on my calculator. That extra, in addition to the $5,000 I started with, the extra amount is the interest amount. So the interest rate is 4%, but the interest amount is $1,353.71 of interest for part 2 of that problem. So if I try to do that using the calculator, I just have to trick it. So if I look at my calculator variables, I know that I leave this at end by default, and nothing told me to change that. I know that I've got 4% APR compounded monthly. I know that I've invested $5,000. The trick here is I have to remember to make that negative. If I don't, it will just flip the signs on a few different things. The signs are much more important if we have payments. If we don't have payments, then the positive negative sign becomes less important. But I think it's good practice to keep up with it. I'm not making any payments, so this is where I start tricking the calculator, because I know I need to solve for the final value, but I can't do that unless these other variables are filled in. So the trick here, as we talked about, is that I'm going to make the payment amount 0. I'm going to say that I pay $0 once a year, and then my number of payments would be 6 years times 1 payment per year, which is just 6. So it kind of allows me to put in my number of years in a way that the calculator will understand. So if I go in and do that, I have 6, 4, negative 5,000, 1 and 12. Go to solve for the final value. And you can see here I've got the $6,353.71. And then I would have to subtract out the 5,000 original principal amount to get my interest value, which I have here. So I'm just going to take my solve here, put the arrow there to show that it's the same thing. And we'll do that again. So just to do a little variety here, we plan to invest in an account that pays 6.2% interest compounded annually. I'm looking at this. We're still solving. Oh, no, we're solving for the principal value. Yeah, let's try this one. So we'll use a different color just for fun. My account pays 6.2% interest compounded annually. Boom, 2 variables right there. I know that this is going to stay at end because it almost always does. How much should you invest? So how much should my principal value be? I'm going to solve for that. I want the account to be worth $50,000. I'm investing it, which means at the end it will belong to me, so I'm going to leave that positive. And 10 years. So I'm going to put my 10 years here. So if I'm doing this by tricking the calculator, then I'm going to put $0 payments once a year and put 1 as my PY, which means that this will just stay as 10. That is one option. Or I could have noticed potentially as I went that there were no payments. I'm just letting the money sit there. So I could have jumped to the formula. And the nice thing about my formula is I never have to worry about positive, negative signs in the same way where I have to like understand calculator language. Let's see, I want my final value to be $50,000. I don't know how much I want to invest, but I do know that it's 6.2% interest. It's compounded once a year, and it's 10 years later. So if I'm solving that on the calculator, I'm going to divide out. So I actually have room here to write this out a little bit more thoroughly. I've got $50,000. And I'm now dividing out all of this. So I would actually have 1.062 raised to the 10th if I were to simplify all of this. You don't need to do that. You could write it out the long way. But if I do that, it just makes it, let's see, 50,000 a little easier to type into the calculator sometimes. So I would need to invest approximately $27,398.38 in the account because 6.2 is actually a really good interest rate and 10 years is a long time. So in that amount of time with that interest rate, this would actually almost double, which is pretty incredible. Or if I had wanted to trick the calculator into doing that for me, I could have entered in my variables as planned here, 50,000, 1 and 1, go back up and alpha solve. And you can see negative $27,398.38. It's listed as negative because it would be located in the bank at the start if this was an investment I was making. Again, that, knowing the positive, negatives, all of that, that is usually the reason if a student in the past has preferred to use the formula where possible. It's usually because they don't have to worry about the positive negatives of the calculator language. But if that doesn't bother you, then you can use either one. So there are 2 more, it looks like, on the back. Well, actually 3 more because we also have an inflation problem here with real terms. So you can feel free to practice on those as well and compare them to what we originally did. See if you get the same thing when you use the solver.